Hi guys, welcome from Connect My Place. We're going to look at MQTT, which is a way of linking together and controlling lots of IoT sensors, equipment, that type of thing. At the heart of MQTT is the concept of pub/sub, which is publish and subscribe, and topics. So take for example an MQTT client which is recording or displaying temperature, and what that can do, it can publish to its own temperature topic, and other devices can subscribe to that and read the value of the temperature. We're going to show you how to use MQTT to control your devices, and in doing so, how one or two simple rules can be pushed out to potentially thousands of devices. I'm going to use a Raspberry Pi to set up an MQTT broker and also a client, and then we're going to use ESP Wi-Fi devices on the same network to set up clients. We're going to show you how to publish MQTT topics and how to subscribe to them, and then once you've got the data is interchanged, how we use that MQTT data. So we have a Raspberry Pi and two Witty Cloud, which are ESP devices on the same network. I've just shown the IP addresses as well. First thing we need to do is to set up the MQTT broker, which is the server, and the client on the Raspberry Pi. And to do that, we follow these commands. The first one, this one I've already done, and that just downloads the requisite programs and installs them. And then I've enabled Mosquito, which is the MQTT broker as a service. Next thing I have to do is to use is to set up a user called test and a password called test by using this command, the mosquito_password command. So what it does, it creates a password file for the user test and sets the password, which I'm also going to call test. So if I run that command and then type in test, again test, and if I cat display password file, you can see that it's encrypted the password. I need then to copy that command to the Mosquito configuration directory, which is etc//Mosquito, and I then need to go in and make changes to the Mosquito configuration file, which is this one. So when I go in, I've already set this up. What I need to do, this will not be in by default. I need to add these commands, the references, the password file, and also set allow anonymous as false. Again, I've got all this, will be provided in the installation instructions below. So basically that's all there is to setting up the client and the broker for Mosquito. Next thing, what I'm going to do is to show you how to connect that to a client, an MQTT client on a Witty Tasmodo device. Okay, we now have to set up the configure MQTT on the Witty Cloud module running Tasmodo. So what we do is we type in the IP address of the Witty Cloud, and the main menu appears. I've also then opened up in another window the console menu. First thing to do is go into configuration, and you'll see there's no reference to MQTT. What you have to do is configure other and go down and click on the MQTT tick box. Enable that, the Witty Cloud will reboot, as will be shown in the console window. And when you now go into the configuration menu, you will find a configure MQTT option, which wasn't there before. Click on that, and I've already pre-populated this. So what you can see is the host name is the IP address of the Pi. The port is defaulted to accept the default of 1883. Accept the client ID given by the Witty Cloud. The username is test, which is what we set up in the Raspberry Pi broker, the MQTT broker. If you remember, we ran the password, MQTT password function, and so we're using that information, the test and the password, which permits us to again connect to the MQTT broker on the Raspberry Pi. So I'm going to save that anyway, and again you'll see that the console window will disappear and then will reappear, and we have some information on this. So what we're showing here, the MQTT means the Witty Cloud is trying to publish to the MQTT broker MQTT topics, and this is one of them. But for us to see that on the Raspberry Pi, what we have to do is to listen to it. So in this case, let's type in tele, T-E-L-E, tele state, and we have using the username and password. And it's not, the Raspberry Pi is now listening to information coming from the Witty Cloud. If I restart the Witty Cloud, hopefully what you'll see is when it restarts, it tries to publish to this topic again, and that should be picked up by the Raspberry Pi. Yep, so there it's coming through now. As you can see, it's the current time information on that. I'm going to come out of that, and one of the things is the MQTT broker does not retain that information by default. So if for some reason you do want to save it to a file, you can just find out where we've got this. You can then save it to another, maybe something like a text file. Sorry, so if I create a text file called, let's say, MQTT log, okay. And then this time what I'll do is I'll output the information on that to that text file. Oh, sorry, permission denied. So what I have to do is just change the permission of that to, I'll change the owner, or change the permission to chmod 777 MQTT log. Yeah, and this time what I'm going to do is I'm going to restart the Witty Cloud again, so that we can force the Witty Cloud on startup to publish that particular topic. Okay, it's done that. Now this time you'll not see it on the screen because we've redirected it to this file, but if I come out from that file, exit the MQTT broker statement and have a look what's in that file, yeah, you can see what we have is the same information which has been published on the Witty Cloud. Okay, in this case what we're doing is we're using, as we did before, we're using the broker to listen to a particular topic which corresponds to with that on the Witty. And what you have here is we're using a topic called Tasmodo _03 power. The stat command actually listens to the status of it, but we can also, and the broker will also coordinate all traffic and information associated with that topic. So it means that what we can do is we can turn first of all, if we can show you, if we toggle the Witty Cloud on and off, you can see that it's appearing on the Pi and also appearing on the console window on the Witty. Now what we can do, as well as, I'll just show that again, toggle it back on. Yeah, you can see it's come on again, both in the broker window and the Pi, and the console window and the Witty. But I can also use a pub command, which is the client, to send a command to the broker, which again is the Pi. And in this case, the Pi, because it's listening in that topic, will actually send a command back to the Witty and turn the power either on or off. So in this case, what I have is, if you can see in this window, I'm going to turn the power off. Yeah, you can see that's off, and it's just to reiterate, I've set it up from this window on the Pi using the pub rather than the sub command. And what I can then do is I can turn it back on by just changing the value from on to off. Yeah, you can see it's come back on again, and it's recorded as well. Again, what you could do is save that as a text file or whatever. It's useful in a number of ways, in that you can remotely turn a device on or off, but you can also then record whole information as to when an event took place. In this case, I'm not sending it to a text file, but I could send it to a text file and record the date, time, and things like that. So that's that part finished. Thus far, we have seen that the broker has been listening into individual topics. There is a way using the hash command, the hash notation, as you can see from here, that the broker can subscribe to all topics from clients connected to that broker. So you can see we've got two Witty cloud modules, 1232 and 1239. If I run this, you can see that the broker is going to see all of the topic information published from both of those Tasmodo devices. Okay, in this case I'm going to show you how to read the light values, which are called analog 0, which are LDRs on the Witty cloud, and you can see at the minute it's 305, 300 and 521 on another. So I want the broker to be able to read specifically those values. So the way I do it is using this command, and I pipe the information to a bash script, which I'm going to show you, and I basically parse out just the information I'm interested in, which is the light values or the LDR values based on analog 0, which will work for both Witty clouds. So what happens is the analog 0 value, when it changes, it publishes to the respective topic, and I can then pull that information out. You can see that it says 308 530 on the screen, and that's now been picked up by the broker. And what I can do with the script then, I may want to, for example, compare it to an upper and lower action limit or warning limit, and then make a notification based on that. So we saw earlier that the broker can basically subscribe to all topics and then parse certain data out of it, and we did that using this mqtt_pipe.sh, which is a bash script. Just having a quick look at the bash script then. So what's happening is the broker is piping the output of all topics into the script, and the script then reads the data, and when it finds the keyword sensor within it, it then parses that individual topic and using the JQ command, and in this case it's looking for time or analog 0. Important thing is that if I then set up a third WIDI PI, by default it will have the sensor set up for the light readings, and it will come in as well, so there's not an awful lot of configuration required. I provided the code within the description of this video. So this time what we're going to do is not only monitor all the topics and those topics with analog or sensor data, and specifically the LDR analog data on the WIDIs, we're also going to use that data to control a WIDI. So in this case you can see that 232 is in the off position and the analog value is 3, which means it's in darkness. I've covered it with something just to emulate darkness. Now if I run the new script, what it should do, it'll determine the value of the LDR of every WIDI, and then specifically if it's less than 200, which is getting into dark conditions, it will turn the WIDI on, which is basically turning a light on. Okay, it's done that. So MQTT is efficient and low cost. I hope we've shown you that you can basically create a rule which can be rolled out automatically or deployed to potentially thousands of devices. The next video will consider security, including HTTPS and also local PI versus, say, cloud MQTT from AWS and Google, etc. Thanks for listening, and please subscribe. You can see that all the scripts and commands are given on in the links in the comments below. And thanks again.